Hello, this is Mr. Anderson from Kellogg Community College for Math 101, Section 8, Part 4, Adding and Subtracting Rational Exponents with Different Denominators. Now, it would help us a little bit if we first took a look at adding and subtracting fractions with common denominators, and then do a quick review of what we would do with a simple fraction with non-common denominators. With common denominators, your adding of fractions with like denominators is pretty straightforward. Since these denominators are the same, you would take your two numerators, add them up, and your answer would be that denominator. It wouldn't change, unlike multiplication and division. You can rewrite that as a decimal, or you can turn it into an improper fraction. In fact, we will probably not be turning anything into an improper fraction, or mixed fraction. We'd probably keep it as improper. So that is a pretty quick review. But what happens when you have two fractions that do not have a common denominator? So here we have two, let's go with 2/8 plus 4/6. Now already we could probably reduce these, but I kind of want to have something that can reduce at the end, but you'll notice that these are not the same denominators. Now one common method, so method number 1, is to choose the multiple method, where you list all the multiples of 6 and 8. Now 6's multiples, 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, times 4 is 24, and we can go on and on and on. But knowing my multiplication tables, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. And that is our common multiple of 24. So we ask ourselves, okay, so I've got 2/8 plus 4/6. What do I multiply the 2/8 by and the 4/6 by to make it a 24? Well, what I'm going to do is, since this is the fourth along here, I need to multiply 6 times 4. So I'm going to multiply the top and bottom by a very fancy 1, a 4 over 4. And I know I decided to go 3 along for my 8, so I'm going to multiply by 3. So 3 times 2 and 3 times 8. So my first fraction then changes into a 6 over 24, and my second fraction changes into a 16 over 24. 16 24ths and 6 24ths, each of these add up to make 22 over 24ths, which can be simplified if I divide top and bottom by 2, 11 over 12. Now that's one method, and it works really easily when the multiples are pretty close together. But if the multiples are not close together and you have to go further apart, I strongly suggest something called the Venn diagram method. And the Venn diagram method takes your 6 and 8 and breaks those into products of primes. The 6 can be broken into 2 times 3, and it already is now a product of primes. 8 can be broken into 2 times 4, and 4 then can be broken into 2 times 2. This product of prime method was originally taught in Math 97 and is used by a lot of high schools across the country. Now, this product of primes, 2 and 3, and this product of primes here, 2 times 2 times 2, we start to look for similarities. And we notice there's a similarity here and here at the end of the tree branches. We will then make a Venn diagram and put the similarity between the 6 and the 8 inside of that intersection of the Venn diagram. What's left over here is a 3, and what's left over here is 2 times 2. Now what that means is that our common denominator can be made if I multiply the 3 times the 8 and multiply the 4, because 2 times 2 makes 4, times the 6. So rewriting my original problem, 2/8, I got to multiply the 8 by 3, which you'll notice is what we did before in the multiple method. Whoops, I shouldn't put a plus there, or equal sign, I should put a plus. And this is going to be 4/6. Noticing I'm multiplying the 6 times 4, the 2 times 2, so that makes a 4 here and a 4 here. Now you'll notice that the same thing is going to happen just like we did in the multiple method. 2 times 3 is 6, 24. 4 times 4 is 16, 24. We get those added up to 22 over 24, which then simplifies to 11/12. So there are two different methods to do a common denominator. Now, you can see that the top level was really quick and easy to find, but that was because the multiples were very close together. They were only 3 in on the mix. When you have multiples that are further away from each other, maybe 7, 8, 9, 12 spots away on the mix, it's going to be easier using the Venn diagram method. And I strongly recommend the Venn diagram method for this chapter when we deal with binomials and also powers of x. Okay, so taking a look at this first problem. 15 and 24, those multiples are not very close. The job right now that we're doing is to just find the common denominator. We're not going to do anything with the numerators at all. So to find the common denominator of 15 and 24, what we'll have to do is list 15 as a product of primes, which is 3 times 5. And since we have x squared, we should probably list all the x's as well. There are 2 x's to make x times x. Now 24 is a little bit trickier animal, and to do that I'm going to kind of move over here a little bit. 24 can be divided into 2 times 12. Now 12 can be divided into 2 times 6, which can then be divided into 2 times 3. So 2 times 2 times 2 times 3 makes 24. And you'll notice that my x to the 5th can be also written with 5 x's. That's really what x to the 5th means. Now, if I make my Venn diagram, you will see how nice Venn diagrams work for finding common denominators. So let's see what we have in common. Each of these has a 3 in the common factor there. So I'm going to put a 3 in the middle. Now over here this has a 5, and over here this has a 2 times 2 times 2. So what I need to do is I then need to also take a look at my x's. Looks like this has 2 x's, 1, 2. This has 2 x's, 1, 2. And this one to the right has 3 leftover x's. So I'm going to put 2 x's here, x and x. And that means this number over here, the 15x squared, is pretty much 15x squared. And this 24x to the 5th is 24, 3, 2, 2, 2, and I need 3 more x's to balance it out. So, what I would need to get my common denominator, I would either need to multiply this by 5, or multiply this 15x squared by 8x cubed. Well, obviously the quickest way to do that would be multiplying this side by 5, so 24x to the 5th multiplying by 5 is going to give me my common denominator of 120x to the 5th. Now I could do the same thing over here. I could take 15 and multiply it by 8, and that would give me 120, and take x cubed and multiply by x squared to get x to the 5th. Now getting common denominators are going to be a little bit easier with binomials at the start here. So this denominator is x minus 5, and this denominator is x minus 7. So when we have two denominators that have nothing to do with each other, like if we had 1/4 plus 1/7, we would multiply this side by 7 over 7, and we'd multiply this side by 4 over 4. Well, the same thing happens here. Since x minus 5 and x plus 7, because of the binomial bond, have nothing in common, because I can't rip apart the 5, or the x, or the 7, or the other x, then I have to multiply this side by x minus 5 and this side by x minus 7. So the common denominator of these two is going to be x minus 5 times the quantity of x plus 7. Or x plus 7 times the quantity of x minus 5. The order doesn't matter. See, with the Venn diagram method, you see we have nothing in common. So we multiply this by this, or this by this. It will give us the same common denominator. We're going to practice two more denominators here. Just getting common denominators, not adding yet. So here, let's get my screen draw rocking. Okay. So you notice on this side, I have x minus 6. Now I can't factor that, but I can factor this into x plus 4, x minus 4. Alright, so I'm going to take my x minus 6 and see what it has in common with x plus 4 and x minus 4. And you'll notice since I made that so small, you can see that I already knew that the x minus 6 has nothing to do with this x squared minus 16 factored into x plus 4, x minus 4. So what I either have to do is multiply this way, or take these two and multiply this way, So the faster way to do it was to take my x minus 6 and say my common denominator is going to be x minus 6 and the quantity of x squared minus 16, which I could rewrite as x minus 6 and x plus 4, x minus 4. So now we have our final problem that has a little bit trickier common denominators. Because in this case I can factor this into x plus 5, x minus 5. Now remember, I'm ignoring the numerators here. I'm just finding a common denominator. And this is going to be x minus 5, x minus 5, because this is an easy trinomial with two numbers multiplying to make 5 and adding to make negative 10. So I've got my Venn diagram, x squared minus 25 and x squared minus 10x plus 25. Now I make my huge overlapping, notice I have some bigger overlap there with the Venn diagram. I notice that this can be factored into x plus 5, x minus 5, and this can be factored into x minus 5, x minus 5. Do these two have anything in common? Well, they do. This one has an x minus 5, and this one also has an x minus 5, so they at least have that in common. But what's left over here is an x plus 5, which now if you focus on the left circle makes x squared minus 25. And this makes an this has an extra x minus 5. And if you focus on the right circle only, this makes x minus 5, x minus 5, which is x minus 10. So I either have to multiply this by x minus 5 or plus 5, or I have to multiply this by x minus 5, and you'd see that that's going to be the common denominator. So I have this factored as x plus 5, x minus 5, and now this term gets multiplied by that, so there's my common denominator. X plus 5, x minus 5, x minus 5. You'll also notice that if I multiply this side, x plus 5, by that, this here gives you x plus 5 multiplied by that, so x plus 5 times x minus 5 is the same thing. You'll notice that if you read for this problem across the center of the circle, you get all of your common denominator as well. All right, let's actually go a little bit deeper because we're going to find common denominators and then we're going to add the numerators. All right, start off with 1, 2, 3, 4, 5, 6. Move that down a little bit. All right. And here we go. On our left-hand side, we've got a denominator of x, and on the right-hand side, we have the denominator of x squared. If you did this the multiple method, you'll notice that x can make x squared if I multiply it by itself, and x squared is already that. So some of you might want to think about the multiple method, where I go 4 times x to get this equal to x squared, and this is already 8x squared. So this is 4x over x squared plus 8 over x squared. So my answer is 4x plus 8 over x squared. Using the Venn diagram method of x and x squared, I can show you the same thing because x can be broken into x squared can be broken into x times x. So see, what I had to do is take my x and multiply it by this one over here, which I did on the multiple method, to get my x squared. You'll note that if I read across the middle here, that is not the common denominator. X cubed is not the common denominator for this problem. The smallest common denominator in this case was x squared. Now it is handy that if you get to the end here, you may want to try to factor out something out of the numerator to see if it can combine with something out of the denominator. And it can't, so this would be my answer for that problem. Now you'll notice here that this is 7 over x plus 4 over 1. So if I make my Venn diagram here, you'll notice that x and 1 don't have a lot in common. In fact, x is just x and 1 is just 1. So what I have to do is multiply this side by 1, which keeps it exactly the same, and multiply this side by x. So the 4 is going to get multiplied by x over x, and the 7 over 4th is going to get, or 7 over x is going to get multiplied by 1 over 1. That's the same thing. So now I have 7 plus 4x over x, and this is over x. Now I can add these together. 4x plus 7, changing the order to be correct, over x. Now if you wrote 7 plus 4x, just change your order. Now in this case, you'll notice if you read across the bottom that this is the common denominator. So it doesn't always work that the number or everything that's written across the middle is the common denominator. All right, got a couple more problems here. All right. So now I have 3 over x and 4 over x minus 6. Now, in the world of the common denominator here, you'll notice that I'll make my little Venn diagram. X and x minus 6 unfortunately do not have anything in common. This just has an x, and this just has an x minus 6. So I'm going to have to multiply the right side by x, and I'm going to multiply the left side by x minus 6. I'm going to spend some time kind of making this look a little nicer with the empty space I have. So 3 times x minus 6 over x times x minus 6 plus 4 times x over x minus 6 times x. Now I can take my numerator and put those together. 3 times x minus 6 plus 4x over x times x minus 6. Now it might be nice to try to simplify the numerator as best as you can. This is 3x minus 18 plus 4x over x times x minus 6. 3x plus 4x is 7x, and the minus 18 over x times x minus 6. Now we would check to see is there anything we can remove from the 7 and the 18 to factor that out, and unfortunately there is not. Okay, quick little modification to this problem. I'm not a fan of subtraction, so I'm going to make this a plus and make that a negative. So that will keep everything the same. So let's go and take a look at our Venn diagram. Our left-hand side has x plus 6. Our right-hand side has x minus 6. They have nothing in common. I know some of you say, well, they have an x in common or a 6. Because of the bond of the binomial, you cannot just remove an x or a 6. So I'm going to have to multiply the right side by x plus 6 and multiply the left side by x minus 6. So 8 times x minus 6 over x plus 6, x minus 6, plus a negative 2 times x plus 6 with x minus 6 also being multiplied by x plus 6. So we now have to combine these because we have now one common denominator of x plus 6, x minus 6, and it's not a good idea to FOIL that out and get that back to a smaller term because you're going to want to keep it like this in case we can do some simplification. So 8x minus 8 times 6, which is 48, minus 2x minus 12, and it's best to get that numerator as small as possible. So 8x minus 2x is 6x, and the negative 48 minus the 12 is going to be negative 60. Ooh, there might be something I can remove here. Let's hope it simplifies, right? And that's going to give me x plus 6, x minus 6. All right, let's take a look at that numerator. Is there something I can remove from that? Yeah, we can remove a 6, and that's going to make x minus 10. But in my denominator, you'll notice that's x plus 6, x minus 6. None of those crisscross or cancel or simplify out, so we're done with the problem. And that takes us to some more challenging problems. 3 more to go. Now you'll notice over here on this side is another subtraction problem. Oh, subtraction. Oh, subtraction. I just make it a plus and make it a negative. Heck, I'm going to do that to the one way over here. Make that a plus and make that a negative. Just get it done. All right, you'll notice on the left-hand side we have an x minus 1. Now this is x minus 1 squared. So this is like 2x minus 1s. So in the Venn diagram, notice I have some overlap there. This x minus 1 is over here too. So this x minus 1 is like having 2 of them. And there's an x minus 1 already here, so really there's nothing to do to the right-hand side at all. You'll notice that this doesn't have anything in it, since there's my x minus 1, so this right-hand side stays exactly the same. But the left-hand side gets multiplied by the right-hand side, so this x minus 1 has to be multiplied by another x minus 1. So what I'm going to rewrite my problem down here, so 7 over x minus 1 gets multiplied by x minus 1. And then I'm going to add the negative 3, and remember there is nothing done over here, so this is just x minus 1 twice. So I'm now going to combine the numerator and factor it out a little bit. 7x minus 7 minus 3 over x minus 1 quantity squared, or x minus 1x minus 1. If I simplify that, it makes 7x minus 10 over x minus 1 quantity squared, or x minus 1x minus 1, and we're done with the problem, since there's nothing that can be done to that numerator. Alright, now this problem here. You'll notice this is x squared minus 5x plus 6. So that can be factored. Can you think of two numbers that multiply to make 6 and add to make a negative 5? That's right, it's x minus 3 and x minus 2. So as I get my Venn diagram ready, my x squared minus 5x plus 6 is going to have an x minus 3 in it and an x minus 2, but my x minus 3 only has an x minus 3. So that's what they have in common, x minus 3. But this one has an x minus 2. Now over here, you have nothing left. So nothing gets multiplied by that left-hand side, which is great. But this right-hand side has to be multiplied by x minus 2. So I've got 3x plus 7 multiplied by nothing times a common denominator of x minus 3, x minus 2. And this right-hand side, that negative 3 has to be multiplied by the x minus 2. And so this is going to be x minus 3, x minus 2. So we got the common denominator now. My numerator, this is going to get distributed here, so it's going to be negative 3x plus 6. So I've got 3x plus 7 minus 3x plus 6 is over x minus 3, x minus 2. Which makes my numerator, the 3x and negative 3x, they simplify to 0, makes lucky 13 all over x minus 3, x minus 2. All right, one more problem to go. I strongly suggest that you maybe pause these videos, replay them, try the problems on your own, and see how they go. All right. Here we have a problem with a lot of factoring in the denominator. So we're going to start off with two numbers that multiply to make negative 24 and add to make negative 2. And those numbers are x minus 6 and x plus 4. Negative 6 and 4 make negative 24. Negative 6 plus 4 make negative 2. Now can you think of two numbers to multiply to make a positive 6 and add to make a negative 7? It's going to be x minus 6 and x minus 1. So, looking at these, my x squared minus 2x minus 24 and x squared minus 7x plus 6, we're going to have our Venn diagram. Overlap here as well. Check out the overlap. Now, what do these have in common? They have x minus 6 in common. Now, on the left-hand side, our x plus 4 is not in common with the right-hand side, which has an x minus 1. So we're going to take our x minus 4, multiply it by this side to get our common denominator, take our x minus 1 and multiply it on that side to get our common denominator. So here we go. I'm going to take my x, this is my problem rewritten. I'm going to take my left side, x minus 6, x plus 4, and multiply it by x minus 1. X minus 1 is up there. So this makes my numerator x squared minus x. Now I'm going to take my subtraction, make it plus negative plus negative x. And I'm going to multiply my x minus 6, x minus 1. I'm going to multiply that and make it into, multiply this side by my x plus 4. Alright, so negative x times positive x is negative x squared. Negative x times positive 4 is negative 4x. So now my denominator is x minus 6, x plus 4, x minus 1. The two x squareds cancel out, or simplify to 0, so my numerator is negative x minus 4x over the common denominator of x minus 6, x plus 4, x minus 1. Now what I can do with my numerator is I can go negative x plus a negative 4x or negative 5x all over the common denominator of x minus 6, x plus 4, and x minus 1. Whew! A little bit of work, but it's worth it.